Hey everyone, my name is Issa, and I want to talk about functions in C++. So ultimately, when we think about functions, we need to think about efficiency and not reinventing the wheel, so to speak. So programming is largely it's largely collaborative, I would say. It's collaborative in the sense that you aren't always using your own code that you wrote from scratch. You're going to be building off of libraries and pieces of code that other people have written. And your first foray into this world of collaborative programming is probably going to be through the usage of functions. So, what is a function exactly? Well, let's take a look at my notes. A function is pretty much a block of code that can be written and reused multiple times. So you can write it once and then use it many times. So look at this count right here that says program ending. If we wanted to do this count multiple times, we could copy paste it for sure. That would work. And then when we run this, boom, we got it printing multiple times. But let's say this is 3 lines. Let's say this is five lines, 10 lines. If we have 10 lines of code, what if it was just like this? And we were just copying and pasting this entire thing over and over and over and over again. Look how hard it is to read this code. I mean, obviously this is just one line, so it doesn't matter that much. And there's more efficient ways to do this, of course. But I hope that kind of illustrates why we maybe want a function. Where instead of doing all this code, instead of typing this over and over and over again, or copying and pasting it over and over and over again, we can, kind of type something a lot smaller, and it'll run all this. To highlight it, let's do an addition. So let's say int x is 5, int y is 15. Okay, so we got two numbers. Nothing crazy. Go check out my video on variables if you haven't covered this yet. So we want to do let's do some math. So let's make int sum. Let's make a sum variable. And we're going to store the result of x and y, x plus y. This is your addition, x, y. Now, if we count sum, and I gotta make sure to use this. So if we count the sum, what is the expected output? 20, right? Boom, we got it. So this is cool. But what if we want to change these numbers? What if we don't want 5 and 15 anymore? Let's say we want 20 and y to be 150. So we could come down here, we could say sum is equal to x plus y, count, sum, and del. But this is already getting really tedious. And this is probably a better example of why we want functions instead of than what I was doing earlier with the program ending. So what can we do? Well, we can make this a function. That way we don't have to do all this multiple times over and over again and just change these two. So let's do that. Let's make a function. So first we need to look at the structure. So let's look at my notes. So I kind of give you the general structure for a function. So the first part is called the return type. That goes right here. This is 1 unit. And it is the value returned by the function. We'll kind of get back to that in a second. So I'm going to make it void for now. Void means nothing returned. And we're going to come back to why I made it void at the end, and we'll change it. So let's give it a name. So the next part is the name, and I'll leave this up here for you guys to follow along. So, oops. Yeah, I'll do this. Okay. So we want to give it a name. Let's do add, because that's what we're doing ultimately. We're adding these two together. Now, to make it a function, you have to add parentheses. Parentheses are what make it function. Notice main has parentheses. main is a function. And there's something special about main, which we'll cover in a later video, kind of beyond the scope of this talk. So now we have this add function. And what we can do is we can literally take our code and put it in here. Now it's going to give us some errors because x and y are no longer in main anymore, which is fine. And actually, one thing I'd like to highlight is x and y, because they were declared in this function between these brackets, main does not know about them. These don't exist here. And we'll kind of come back to this. This is the idea of scope. So I'm going to comment this out instead of deleting, and we'll come back to it. So now we have this add function. So now, instead of typing all this out in main multiple times, we can just say add. And I can do it multiple times. Look, so this is calling the add function. And look, so I can do this multiple times. And it's going to run everything in here, and I can even prove it. Before sum, after sum. So it's doing all this every single time we call it, as you can see here. So that's cool. That's cool and all. But right now, it's hard coded. These are hard coded values. It's always going to be 5 and 15. What if we want to change that? Well, that's kind of where this last part of arguments. I also call it parameter. I use those interchangeably. Not always. What's it called? Not always. Like this is semantics. They're not technically the same thing, but for our purposes, they're close enough. Don't worry too much about semantics here. So I'm gonna get rid of these just to clean it up, because we've proven that it works. Now, what if let's say we don't wanna hard code these in. We want the user or the person calling the function to specify them. So that's our argument. That's where these are. So we can give it an argument. We can say, hey, you're taking in an integer a and an integer b. Now the names don't matter except inside here. So if I take this out for now, and I change x to a and b to y, or y to b, now you see it'll work, but look at all these errors. And I'm going to get rid of them because we don't need that many. Maybe I'll keep one. So now it's giving us an error. It's saying, hey, no matching function. Because this one has 0 arguments. This is an empty, no arguments. Well, this one is taking in 2. The compiler's expecting 2. So if I specify numbers here, 5 and 15, now it's fine. Now let me also do this here. So let's do 20 and 150. Now, so this was the same as before when we had them hard coded in the function. But now it's changed. The number have changed. It's now 20 plus 150, and we can verify that with a calculator. These are small enough numbers that I can do this in my head, but like you could test this with any number. Should work as intended. So cool, right? So this is pretty handy. Now instead of doing what I was doing down here, where I had to change, 20 and x and y manually every time I wanted to do it, now it's right here. That's pretty handy. Now, the next thing I want to talk about is this idea of return. So we talked about return types, and I made it void. So basically what I was saying is, hey, function, I'm not going to give anything out. I don't want you to give anything back. So when we call it, we can think of it, this little drawing I made, we can think of a function as input. As inputs and outputs. So like you have a function right here. So this is like our add function right here. And we're giving it 2 numbers. So, we're giving it 5, we're giving it 15. Those are our inputs. And then our output, well, we don't have an output because this is void. We're saying, hey, we're not doing an output. But let's say we wanted to do an output. Let's say we wanted to, I don't know, why don't we give the output as the sum? So the sum, whatever is calculated, is our output. Well, in order to do that, we would need to change this to an int return type. Int because our sum is an int, and we want to return our sum. Now we would need to return sum. So if I run this, nothing really happens on paper, right? Like, it doesn't look like anything happened. I mean, it still prints as normal. But let me take this out again. Let's change this back to void. If right now, ignoring this line, there is no way to work with this value or to save this value outside of the function. Like, if I comment this out, it's doing the calculation, but we're losing the total. Like, the 20 in this line, yeah, it does the calculation, but it's wasted. We don't have a way of saving it, so we can't like save it somewhere. But if we make this an int and return it, now we can say, hey, int answer equal to the value calculated and returned by this function. So now I can say answer. And now it prints out the answer in main. But we can also use answer for other stuff. We can also say answer plus plus, which is going to add 1 to answer. And now this should be 21. So returning is actually super powerful. Especially. The other thing we can do is, instead of storing it into a variable, let's just do this. Let's take this add and let's stick it right here. So instead of storing in a variable, we can just store print out the result of the add. And it looks like it works okay. So, and that's kind of exactly what I did here. So I pretty much remade the add function that I have in my notes. And I did leave some comments. You should definitely check this out. Again, these notes will be linked in the description. And also, just while we're talking about this, I have a Discord. You should totally join. So if these have been valuable, these videos and these notes have been valuable, you should really pop by the Discord. I'm going to be posting these, every once in a while as I'm making them. I'm currently working on like 3 at a time. And I have them for multiple languages. So this is assembly. This is a little bit lower level. And then we have, other languages you can chat with people. Also games in here. Got some people who play games. So definitely join it. Link in the description. Also, make sure you subscribe if these are helping. Leave a comment if if there's any questions you have or any topics I should consider covering next. Anyways, let's get back to the functions. So we've talked about returning. So you can return pretty much anything. You can make this a boolean. You can make this a float. Any pretty much anything any data type you can think of, we can work with. I think I do have a little list. Yeah, I have a little list. And booleans are actually super interesting because let's say you don't need to return this value. Maybe all you want to do is print it, but you want to say that it ran correctly. You want to say, let's change this to boolean, and you want to say return true. Program executed, or I should say function executed correctly. And that's something I'll do pretty often, especially with like functions that don't need to do anything but just run code. Like, I'll be like, hey, yeah, it worked fine. That way you can kind of do a check for it. But in this case, we will want it to return an int. So we're going to leave it like this. Now, I want to talk about variables inside functions. So there's this idea of scope, and I kind of alluded to it earlier with this part. When you make a variable, so like sum a, b, in a function or in a different scope, a scope is defined as these braces. They're like kind of like sections of code. we those variables live only in that scope. They're called local variables. So like sum does not exist outside of this function. So if I try to print sum, it's gonna give me an error. It's gonna be like, hey, I don't know what that is. It's the undeclared identifier. So it doesn't know what that is. And the reason it doesn't know what that is because sum doesn't live inside main. It lives inside add. And this is really important to understand that these variables, where they're created, they die. So at the end of main, answer is gonna die. Answer is gonna die when we get to this, really when we get here, but when we get to the end of the scope. And same thing for the sum. Sum is created here. It's gonna die here. Now, if we make a variable outside of the scope, so if I make this is called a global variable. So I make, sum, let's make sum up here. And then I take away the declare because it's already declared. Now, this will work fine because it is outside both of these scopes. So I like to think of scopes as like a big box. So like this would be your global. Then here's your main. And then here's your add. So if we make sum here, so here's sum, it's only in this box. So anything within this add box, so if we had more scopes, so like we could make an empty scope like right here. So we can use sum here. Like sum will work fine, no problem. Like if I count sum, like that will work, no problem. Because it's inside where this was declared. But yeah, and that's fine and dandy, but it won't be accessed from main. If I make it up here like I did in code, now both main and add can see that sum because sum's in the bigger container. Scopes are very tricky concept. It's not very intuitive, but once you get it, it starts to make sense. So I'm gonna get rid of this. Go put this back and boom. And now we're back to how we were before. Now, the last thing that I want to talk about for this video, and I know it's kind of been dragging on a little bit, is, and I talk about it right here. Perfect. You can read this if you want to quickly, review and better understand it. The last thing I want to talk about is this idea of passing as arguments versus parameters. I did say there was a little bit of a semantic difference. The difference is arguments refer to the numbers. So like I'm passing 5 and 15. But like let's say we had int x, and let's use different numbers. Let's use 25 and y will be 30, 357. I don't know. It doesn't matter really. I'm gonna get rid of this. So instead of passing numbers, this would be like these would be arguments. The numbers. So these numbers are literally being assigned to a and b. So like a now becomes 5 when we come to this function. So a is 5, then we say a, which is 5, plus b, which is 15, and we store that total. Now we have x and y; these are already variables. So if I make this add function, so if I say add x and y, the reason there's a difference between parameters and arguments is because arguments refers to the value, while the parameter is just the variable itself in the function. So when I pass x and y, what do you think is going to happen? And I'm gonna count. I don't think I need to, because this counts. Yeah. So I'm just gonna count, and it's gonna double up because I'm counting it twice. But whatever. So 382 is that number from here. So what's happening is the value inside 25 is being sent. So the value inside x is being copied over to a, and the value inside y is being copied over to b in the function. It's a little tricky, and eventually we're going to get to this idea of pass by value, pass by reference. That's kind of beyond the scope of this video right now. But I want you to be aware that this variable itself isn't becoming A. It's being copied to A. In any case, I want you to take out this challenge. I want you to try out this challenge problem, and just try and read. Just try. It's not a very hard function. All we're gonna do is you're gonna use this count, and you're gonna print something. So one of your parameters, I'm not even gonna tell you how to do it. You're gonna give it like what we did here, and it's gonna be a string. So you're gonna put some text in, and what's gonna happen is it's gonna print that text out to the screen. This isn't literal, like some text here. You can put whatever text you want in here. I want you to try it, and when you do got it, and you think you got it, come to the Discord and post it. Link will be in the description, as I said already. I'm looking forward to seeing this. Alrighty, have a good day.